Hey everyone, in today's lesson from Unit 3.2, Part 1, we'll be taking a look at the 5 ways in which we can prove that a quadrilateral is a parallelogram. So, in the first case, we can use the definition of a parallelogram. If we can show that both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So we can say that if line segment AB is parallel to DC, and if we can show that line segment AD is parallel to BC, then we can say that ABCD is indeed a parallelogram. The second way we can prove that a quadrilateral is a parallelogram is by using a converse of one of our earlier theorems. If we show that both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if we can show that line segment AB is congruent to DC this time, and at the same time line segment AD is congruent to BC, then we have a parallelogram for sure. In the third case, this is also a converse of an earlier theorem. If we can show that both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we'd have to show that angle A is congruent to angle C, and angle B is congruent to angle D. Again, it has to be both pairs, can't just be one pair of opposite angles congruent. In our next method, if we can prove that one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if we prove that line segment AB is congruent to line segment DC, and we prove that AB is parallel to DC, then ABCD is a parallelogram. Again, that's one pair of opposite sides, must be both congruent and parallel. Then we've got a parallelogram. Okay, finally, if we can prove that the diagonals of a quadrilateral bisect each other, then the quadrilateral must be a parallelogram. So if we draw on those two diagonals, let's label that point of intersection of the two diagonals point B. So if we show that line segment AE is congruent to line segment CE, and if we show that line segment DE is congruent to BE, then we definitely have a parallelogram. Okay, take a look at your CYU and practice, and when you are determining if a quadrilateral is a parallelogram, you're going to need to state the reason why. Okay, so you need to state the theorem or the definition that you used to show that the quadrilateral is a parallelogram. In some cases, we're also going to be doing algebra. We're going to solve for a value of x or a value of y that's going to make the quadrilateral into a parallelogram. But keep in mind, you're still applying the theorems and the definition of a parallelogram. Good luck.